Why am I starting this video with an almost fully disassembled knife? Well, simple. This knife's name is Disassembly. Yes, that's what the creators at Remette creatively called it, Disassembly. Don't worry, this is still a full-up CBRX style review with hardness test and everything else that I do, and then some. But I wanted to start here and show off what makes this knife so unique. Simply because if you were to search YouTube for Remette WD1-D knife disassembly, all you're going to get are a few shorts, flicking the knife and pulling it apart, taking the back shell off. Here's Remette's own video on that exact topic. And then there's some full-length reviews, mostly focusing on how the screws are invisible. And then there's one that is titled, "This knife actually sings when you open it." The quality of machining is impeccable. Look at how complex this piece is, or actual assembly. Look at that. The pocket clip has hidden screws right here. The lock bar / spring mechanism. It's properly machined with nice radii in the stress zones. And then it has triple screw attachment as opposed to pretty much any other knife I reviewed with this type of lock bar that uses 2 screws. Captive pivot hardware. Look at these pockets. The removable cover that hides all these screws and milling inside the frame. A lot of people will say, well, it's integral titanium milling, therefore that part makes this knife so expensive. And in this case, in this specific case, they're correct. Because if you take a more traditional integral knife, you will see that the machining or the milling on the interior is done in one pass of a tool. Well, it could be multiple passes, but it's one continuous line and it just goes right through and mills it out. And once your machine is set up, it is not a particularly difficult operation, but where the savings later come in during assembly, now you don't have to deal with keeping the 2 sides of the knife parallel to each other, because by design and through the milling, they are already parallel. Any extra expenses that go into milling a solid piece of titanium are then overcome by the ease of assembly. Now, this is not the case here, because this milling here required 3-dimensional or 3-axis machine, as opposed to 2 axes on this guy. Because not only did they channel it out, but they also had to tilt the part to mill out this angled pocket right here. So all in all, a very complex part from the machining standpoint. So obviously they spared no manufacturing expense in making this knife, which tells me this is their hello world piece. That's what I call when the company creates this piece that shows off their capability, brings it to the blade shows. And that's how they solicit the OEM business. Or if they are trying to get into direct sales, that also helps them to gain momentum. Let's talk about other parts. So this is another complex part that is simultaneously a backspacer and a housing for this little spring-loaded switch that you press on in order to remove the back shell off of the handle. This part looks like it belongs on a competition pistol rather than a pocket knife. It's also very lightweight. It does not look like metal injection molding. I am totally nerding out on this piece. Did they powder form it and then cinched it? If it's titanium, can you even cinch titanium parts? I bet somebody will comment on that topic. For now, I'll go with an assumption that it is milled. And of course, in-house made pivot hardware, very precisely made pins. This is not a pin that you buy out of a catalog. It's machined individually. You can see the cutoff circle here. It's hard for me not to admire this knife. I'm a total nerd when it comes to machining and manufacturing engineering. And the artist in me admires the blade. A very cool sculpted thumb stud. Beautifully anodized blue. Including this one and only visible screw. But the placement is not something I favor, because anytime I want to sharpen it, especially if I'm using a fixed angle sharpener, I'd have to remove it. And I already tried removing it, and it's Loctite. You know, it's ready for nuclear catastrophe. It's so tight there. So I'm not going to remove it because there's no need to sharpen it yet. Now let's hit a little ugly spot that I found, and some of you most observant viewers already noticed it. Right here where they grind the interface between the blade and the end of the lock bar. The lock bar, by the way, is steel, so there's no need for an insert. It's already a piece of steel. It's a locking interface, but if you were to apply stress to the blade, there's a potential for issues. So whoever ground this got overzealous and went a little too fast. Now let's go back to the good things. It's a solid brass cage bearing, not stamped, multi-row or double row, and these are steel bolts. How do I know they're steel bolts? Because my magnetic base on this iMini flashlight attracts the bolts, since the brass is non-magnetic. And then they have washers that protect titanium from being grooved by these bolts. Now I'm going to reassemble this knife, but that should be a topic for a separate video. This is just a review. For some reason in all these videos, including Remette's own, I see people swiveling this in, but you really don't have to do this. Goes straight in. There you go. I don't think it sings. I don't hear any singing. And so now we can give it a quick ergonomic review. Excellent ergonomics. Here it is. It doesn't feel overly heavy for its size. It's a large blade. And let's throw it on the scale. It comes up in grams first. No offense, my American friends. 139-ish grams. And for comparison, the Excalibur is about 164 grams. And in ounces, it is 5.8 ounces, and this guy is 4.9 ounces. So a little less than an ounce difference. I'm not sure how it would feel in a pocket because pretty crisp angle here. Let's just go ahead and find out. No problem in or out. And the opening methods, here's my Spidey flick, no problem, no wrist. And here's the thumb flick, no problem. And here's the flipper, and that is a definite light switch action because it's pretty strong detent, right? So I definitely couldn't push it in like a button push. Are we ready for the hardness test? Today I'm going to do something different. I pointed the camera downward a little bit so that you can see what I'm doing. The footage is accelerated to X for your time's sake, and I'm voicing over. Here's my certificate that came with this calibration block. It's serialized and rated 62 HRC on the paperwork and on the block. And I do this calibration verification before every hardness test for all my videos. Due diligence. That said, approximately 50% of my viewers are actual subscribers. And those folks who are not subscribed yet, I have a question for you. Do you see this level of diligence anywhere else? I would like to know if there is another channel who goes through those same lengths, and I would definitely subscribe to them. All right. I got 61.9 HRC. We would call it spot on calibration. And now I'm picking which side of the blade should I test. I'm going to the side that is not engaging the detent ball on the lock bar. This is M390 steel. Typical heat treat for these runs anywhere between 58 and 62 HRC. And of course, in the EDC community, we prefer 60 to 62. And that's why when I saw 58.5, I was shocked. Super shocked, but I pressed on because I need to get an average of at least 3 pokes to have some kind of reliable result. Hit a like if you like due diligence. So I was very relieved that on the second poke I got 62.0, but also flabbergasted because why such a jump? This is almost 4, like 3.5 points jump. I pressed on to see which one of these two was an outlier. Outlier is a bad result that you typically throw away before calculating the average. I was holding my breath and exhaled only when I saw that the third poke was 61.6 HRC. Turns out it was the thumb stud that was touching the anvil, the slope portion of it, on the first poke and skewing the result. My apologies if you experienced stroke-like condition when you first saw it. My bad, it's really awkward to work between the Rockwell tester and the camera, and the angle is just wrong to see everything that I'm doing. I'm doing my best here, guys, and I really appreciate all your support that helps me go on. I got 61.7 HRC on the fourth and final poke, and the average for this blade is a very respectable for M390 steel, 61.8 HRC. I am doubly relieved because A, I like this blade, and B, Remette reached out to me and asked to review another fancy knife of theirs, and it's on the way as we speak. Don't go anywhere because next I'm going to measure behind the edge thickness and look at the edge under the microscope. Typically I start my review of the edge at the tip, and this tip is near perfect. There's no radius in the front, and the grind is consistent as I'm sliding the microscope back towards the sharpening choil. I'm still in the belly at this point. The magnification is approximately 40 to 50x right now, and I'm rotating the blade so that you can see how fine the apex is. There's almost an invisible line at the apex. That means that not only did they perfectly hone it and removed all the burr, but also that they stropped it really finely. Let me split the screen here and show you the behind the edge measurement. If you feel rattled by touching the edge with a hardened piece of metal, worry not. I measured the hardness of these jaws, and they're 54 and 52 HRC. So this blade is 8 to 10 points harder than the jaws. And I got 16 thousandths of an inch near the sharpening tool. Let me take another measurement. I'm having a little difficulty lining up. I'm getting 17 and a half thousandths of an inch. If you were tracking what's on the left screen, you probably noticed that the sharpening angle changed ever so slightly near the sharpening tool on the show side of the knife. So everybody talks about the edge or secondary bevel angle, but nobody ever talks about the primary bevel angle. So here's what I'm trying to do, is find out how they angled the primary grind, which is hollowed again. So I zeroed it out on the flat of the blade. The blade is on 2 magnets, and I am measuring 4.6 degrees roughly mid blade. For comparison, here's Hinderer XM-18, and the same measurement shows variation in the slicia grind from around 5.5 degrees down to 4.6 degrees toward the tip. Both of these knives have 34 to 40 degree edge angle, so this Remette will have a slight advantage over the Hinderer as far as slicing performance goes. But why speculate? Let's try to measure. I'm using Newton meter set to newtons. I'll give you results in pounds of force as well. And it's set to peak, so when I press the blade through this cardboard, it will end up showing you the highest force that was exerted on this slice. Here you go. And we got 31.9 newtons. And now let's do the Remette. Reset the 0 here. Here you go. 17.8 newtons. Wow. Would the hollow grind make such a difference? Let's try it again. Back to the Hinderer XM-18. And we got... I did it again. I hit the power button instead of 0 button. Frustration. Let's start over. turn it on. Use this time to hit a subscribe button, please, or like the video. Anyway, here we go again. I'm set. Okay. 33.3 newtons, very close to the original result. And how about the Disassembly? I don't like this name. Very not creative. 25.6. Okay. No, I guess I'll have to do it again just to make sure I'm not reading some kind of false results. And now I'm going to press closer to the tip of this XM-18 blade. I got 21.2. That's where it's sliciest, hence the slicier grind that was pioneered by Rick Hinderer. And sorry about the angle here. I am going for it. 22.2. So let's take a look at the results here. Here are the cuts. H stands for Hinderer, R for Remette. And here are the averages calculations in newtons. For Hinderer, 28.8 Newton average, which equals to, let's say, 6.5, 6.5 pounds of force. And for the Remette, we got 21.8 Newtons average, which is 4.9 pounds of force. So 1.5 pound of force reduction. It is pretty significant. What do we got? 7 newtons. You know, if you're cutting cardboard for a long time, you would definitely feel the difference. But if you're doing 1 or 2 cuts, you will not. Another observation, because of the flat grind here, look how Hinderer sort of pushes its way through the cardboard. You can see the quality of the cut as opposed to hollow grind on a Remette, giving you a much cleaner cut. Draw your own conclusions. And if you enjoy this kind of nerdy stuff, right about now you will see my logo pop on the screen. Please click on it to subscribe or even become a monthly member if you would like to support my channel on a regular basis.